My boss was there for an employee enrichment day, so she signed us up to take some coffee break.
Takes his glasses off, really
Really
nice.
touched me.
He takes his glasses off, really nice.
It's a great dog.
Strong. Good morning, everyone.
Morning.
Nice to see you back again this week. We will shortly be talking about genetics and biological proofs or disproofs for evolution. But first, let's open with a word of prayer. Almighty God and Father, creator of all that exists, we thank you for your first article gifts of life and food and clothing and all of the other ways by which you give support and preservation to our earthly lives. We also thank you for your third article gifts, the way you work through your Holy Spirit to call us to faith and to strengthen us in that same walk with you. And so we ask that you would send your Spirit to be with us now, that as we look at your word and especially the teachings of evolution and creationism, that you would give us discerning hearts to know and to recognize falsehood and truth and to be able to make that distinction in our hearts and in our lives. We ask this for Jesus' sake. Amen. All right, we have a few folks that are here today that weren't here last week. So just to go over what we covered last week, I'm going to turn it over to one of you. When it came to astronomy, what was the main problem for creationists when it came to astronomy? Nobody remembers? If stars are millions of light years away, and a light year is how fast light can travel in the span of a year, the problem was,
How could they see it already?
in the Garden of Eden. Yeah, if God made stars and other things in the heavens for the benefit of Adam and Eve, how could it benefit them if they couldn't see them? And of course the solution to that problem is, what kind of universe did God create?
Mature.
Mature. Everything already worked. Everything was already old when he made it. Adam and Eve were not infants. They were, at the very least, teenagers, probably 20-somethings. Trees had rings in them. The levels of salt in the oceans already had a high concentration of salt. Just anything you can think of. It was already old. It already had the appearance of being old. So that's the solution to the problem is when God made everything, it was already working. It was already able to fulfill its purpose for which God created it. And that included the light from stars. It was already at the earth as though it had been in transit for millions of years. So the mature universe helps to explain so much of the phenomenon that people have observed and said, this rock appears to be millions of years old. Well, either your dating is faulty or it's accurate, and when God made it 7,000 years ago or so, it already was millions of years old, at least according to however you want to date those things. So that's the explanation for how light could be here and how rocks can appear to be millions of years old, etc. All right, moving on, today's new stuff. Another support for creationism, or intelligent design for that matter, is the anthropic principle. Did you need something, Gary, or you're just sitting in?
Just joining.
All right.
Thank you.
The anthropic principle.
Are you on genetics or something?
Not yet, I'm still under astronomy.
Okay.
So still under astronomy, another support for that is the anthropic principle. And what that principle states is that the universe is especially suited for the well-being of mankind. The universe is especially suited for the well-being of mankind, people on Earth. Not other planets, but Earth. What are some examples of that? Well, I think you have them listed on your page, don't you? Maybe you don't, I don't know.
No.
All right. Well, for starters, the distance of the moon from the Earth. What does that provide for human beings?
Tides.
Light, the tides, the gravitational pull that leads to the tides. It's exactly the right distance from the Earth in order to sustain human life. If it was closer or further, human beings couldn't exist. But it's just in the right place. The amount of oxygen content in the air. Did you know that you could have too much oxygen in the air? Yeah. And if you had too much oxygen, then you wouldn't have the other gases in the air that are necessary for human life. So what is it, like 16% is the oxygen content of clean air anyway? I know that sometimes football players will breathe in pure oxygen. I don't know if it's 100% pure oxygen or not, but I'm sure that they couldn't survive on that. It's just a way of regenerating their body on a short basis. The laws of gravity, which is based on our distance from the sun, and I don't know if it's connected to other planets or not, but certainly our distance from the sun makes gravity just the right amount. Some of you might prefer if we had a little less gravity, because then you could maybe bounce a little bit when you walk, but then that would make everything else less likely to stay where it is, and then you'd have to deal with all those things floating around. So God created the earth and all of the laws that govern it to be just right for the existence of humanity. That's called the anthropic principle, that all of these things exist in just the right amount to make it possible for humanity to thrive. Now, the most commonly cited argument against the Big Bang is the law of conservation of matter and energy. Again, it's a law of the conservation of matter and energy. And the reason why that is cited against the Big Bang is it states that matter and energy must come from somewhere. They do not and they cannot self-exist. So, in other words, matter and energy has to come from somewhere, something, some action must create this matter and this energy. They cannot self-exist. What does the Big Bang say? That everything self-existed without a creator, and then, exploded and everything else that followed after that. But there's a law that says that's not possible. The second most cited argument against the Big Bang is the second law of thermodynamics. The second law of thermodynamics, which says that things do not go from chaotic to order, or from chaos to order. That's not how things work. It doesn't work for us. It doesn't work for the vehicles we drive, the houses we live in. There's nothing in all of creation that gets more complex, more, what's the word I'm looking for? More perfect as time goes on. As the second law of thermodynamics says, everything breaks down over time. It does not go from chaos to order, it goes from order to chaos. Instead, getting back to the handout, all things break down over time. And they become more simple, not more complex. Now again, all of this is presupposing a certain fact that I haven't mentioned, but I'll get to it. But just thinking of ourselves as human beings, I know that when we were in our 20s, we all thought that was our best time, that was our peak. But in reality, our bodies were breaking down even in our 20s. Not as quickly as they are as you get older, but you were at your peak of existence when you were born, and it's been downhill ever since. I don't know if that's exactly true, but certainly as time goes on, we as human beings, we do not get more complex, we get simpler. You know the cars you drive, the house you live in, anything. It breaks down over time. The Big Bang Theory presupposes that the universe actually built itself up over time, gaining in complexity and order. So, again, if you're going to believe the Big Bang Theory is true, then you have to believe that the universe got more complex as time went on. Everything started out as a simple thing, and it evolved and became more and more complex, which is not at all what we observe in nature. Now, this law, the second law of thermodynamics, can only be overcome by directed energy. In other words, an outside force intervening, acting to prevent or change the second law of thermodynamics. And that's what gives credence to the theory of intelligent design. In other words, we were designed by an intelligent being. Not necessarily God, according to them, but certainly some kind of creator who in his intelligence, or her intelligence, maybe it has no gender at all, I don't know, but in their intelligence was able to make things more complex, more ordered. Now that's the theory of intelligent design. That's not the same as creationism. Please understand there is a difference. It is the scientific way of trying to get a form of creationism into schools, but it's not creationism. It doesn't talk about the creator as being a god. It just says it's a designer. All right, before we move on from astronomy, do you have any questions? If not, we'll move on to the heart of the matter, genetics and biological evolution. Biological evolution says, as we've discussed before, organisms gain in complexity and information through mutations. So organisms gain in complexity and information. They become more sophisticated, have more depth through mutations. And then those mutations are sifted out by natural selection. So, if a mutation is going to be helpful for an organism, natural selection will allow it to keep that adaptation and then pass it on to their offspring. If it's not a helpful adaptation, then natural selection will kind of weed it out. By the way, that's what Darwinism is all about. I don't know if you've heard somebody say something along the lines of Darwinism wins again, but it basically just means when someone does something really dumb and it causes them to die or suffer greatly. So that's what that phrase means, Darwinism wins again, or something like that. It's just making reference to the fact that natural selection sorts out the things that are helpful and not helpful, and when people do dumb things, it's not helpful to them. All right, now, if organisms are going to gain in complexity information, these changes must take place at the molecular level. So you don't just change an arm. You change your DNA to create that extra arm. In your DNA, it tells you exactly how many arms you should have. And what do you know? We all have 2. Some people have more, and that's not something that proves evolution. What it proves is they've got something in their genetic makeup that's different from everybody else. Or if they have no arms, that's part of their genetic makeup. So that information is hardwired into us at the molecular level. And then it can be seen at the organ level, or I don't know what you want to call it, appendages. It could be internal, could be external. I couldn't think of a word for it, so I just stuck with organ. But before you can have all of these changes take place in a way that's visible to other people, first it has to take place inside your cells. In other words, a leg can't turn into a wing unless this change takes place first at the genetic level. So your genes have to change first. Which I think I'll mention later, but in case I don't, that hasn't been observed in nature either. There's a fly experiment that I'm going to talk about a little later, I think. And they blasted those flies with as much radiation as possible, and those flies mutated in all kinds of ways, but after 10,000 generations, they were still flies. They hadn't changed in any other creature, even though there was 10,000 generations of them. I imagine they were kind of weird, but they were still flies. All right, getting back to the handout. Supposed proofs for biological evolution. The idea of inherited characteristics explains how organisms can evolve. Inherited characteristics, that's when mom and dad have a baby. That baby inherits the characteristics of their parents. Jake, for example, our son Jake, has gout. Why? Because Tracy has gout. He inherited that from her. And that's a genetic condition. I mean, my daughter's ornery, but that's not a genetic condition. That's nurture, that's not nature. And I'm sure she got that from Tracy as well. All right, so when mutation happens, the DNA is altered, and new information is introduced to the genetic codes of an organism. So let me say that again. When a mutation happens, by the way, this is what they say. This is not what actually happens. This is what they say. When a mutation happens, the DNA is altered, and new information is introduced into the genetic codes of a particular organism. So, if new information is being inherited, shall we say, and it's being introduced, then if enough new information gets inherited, then through mutations or breeding, there is a change that will take place in the organism over time and make it into a new organism. Again, this is not what is observed in science. This is what they say. They have to say that, because how else would you explain evolution? If things are more complex now, they say, than they used to be, then things have to be getting more complex over time. Well, how do things get more complex? Mutations. And then natural selection sifts out. Now that, again, that's observable. Mutations and natural selection, that's observable. What's not observable is that anything ever becomes more complex after it's mutated. So these mutations, this is the next point, can be caused by changes in the environment, in other words, chemical changes, poisoned water, it's got some sort of, some sort of chemical in the water that is harmful to people. And so if they were to drink it, they'll die. I don't know. We've seen this example before, and this is observable. Well, here's one. Anybody have seasonal allergies, like during the fall? I do. And what causes that? Well, as far as I know, farmers out in the fields, kicking up dust everywhere. Not around here because it's been raining, of course, but when it's dry, they kick up a lot of dust when they're working. And I'm not saying that they shouldn't do their jobs. I'm just saying that some of us who have seasonal allergies suffer because of it. It's just the way it goes. But that would be an example of a chemical change. The air is chemically changed and now it affects me. That would be an example of that. Another example of changes in the environment would be radiation. Again, if you live too close to Chernobyl, you may suffer the after effects of that. Does anybody know what Chernobyl is? I'm mentioning things, but maybe people don't know. Does anybody know what Chernobyl is?
No.
Wow, okay. Chernobyl was a Russian power plant?
Yes.
Nuclear power plant. And there was it an explosion or did it just,
Both.
it overheated and exploded and
Melted down.
for miles all around people suffered radiation poisoning and died and whatnot.
Still do.
And still do, yeah, radiation doesn't exactly go away, it just hangs around.
Where was
Yeah.
this at again?
It's in Russia, or at that time Soviet Union.
No, it's in Ukraine.
Well, but at that time it would have been Soviet Union, right?
Right.
Before they broke up.
Right.
Yeah. But although you mention that, now that you mention that, Ukraine, that's what we're fighting for. We're not fighting, but that's what some Americans are fighting for. And lots of Ukrainians and Russians are fighting for it. And why would you want that place? It's all poisoned anyway. In more than one way, by the way. I think, well, I'm not going to get into politics. But some of the Ukraine, again, I don't know if that's true, but I'm going to trust Jeff because he's a smart guy.
Yeah.
And so I'm just assuming that it's true that they're fighting over that piece of land and some of it's damaged by radiation. I don't know.
But some of it is also very fertile farms, land.
Yeah?
They say the wild population around the power plant is unbelievable.
Meaning it's unbelievably good or bad?
Yes, good, because humans are gone,
Yeah.
and so it's just become a mecca for
Wildlife.
wildlife.
It's an interesting lesson in anthropology. Where there are less humans, there are more animals.
Oh, absolutely.
All right, next point. Evolutionists claim that if mutation is harmful, it will be eliminated by natural selection. So evolutionists claim that if a mutation is harmful, it will be eliminated by natural selection. But if it's beneficial, it will remain. That's what they claim. That if a mutation is harmful, it will be eliminated by natural selection. Where did I lose you?
The one before, the blank before.
In the environment or by.
Radiation. So that was the previous point. This point is evolutionists claim that if a mutation is harmful, it will be eliminated by natural selection. But if it's beneficial, it will remain. That's true, that's how natural selection works. However, this is what they won't admit to. All mutations are harmful at the cellular level. So every type of mutation that happens is harmful to that organism at the cellular level. Now, it might lead to benefits, like when a fly becomes resistant to pesticide. On the one hand, genetically speaking, that's harmful to the fly. Now, existentially speaking, it's helpful for the fly because now he's not going to be killed by that particular poison. So all mutations are harmful at the cellular level or genetic level, which must change first before tissues can change. So everything has to happen at the cellular level, at the DNA level, before tissues themselves can change. Whether it's brain tissue or arm tissue or liver tissue or whatever, all changes must take place at the cellular level first. Now, again, this is what evolutionists will point out. Chemically speaking, humans are 97% similar to monkeys. Raise your hand if you've ever heard, I don't know if that number is exactly the number you've heard, but if you've heard that we are statistically very close to monkeys.
Just heard recently.
Yeah. Now, do you know what that's based on? It's based on something called blood precipitation. In other words, our blood is very similar to their blood, which is why so many of the other features are similar. We have 2 arms and 2 legs. We don't have a tail, they do. We're not as hairy as monkeys. But that's what it's based on, it's blood precipitation. However, different tests show that there are chemical similarities that make humans similar to other organisms as well. So depending on what you're testing, this is the point, depending on what physical properties you are testing, humans are actually quite similar to a variety of different organisms, such as donkeys. If you evaluate milk chemicals, okay, so the milk that's inside of human beings is similar to the milk inside of donkeys. Snakes, if you look at cholesterol chemicals. I don't know that any evolutionists have ever said we're closely related to snakes, but we are when it comes to cholesterol. Chickens, that's tear enzymes. And even the butter bean. based on another form of blood chemistry.
What?
Butterbean,
Bean.
Okay.
butterbean,
I was like, what is
it's a bean.
that? I know, I don't understand you.
Everybody know what a butterbean is? It's, looks like a regular bean, but it's the color of the walls in here.
So
All right. Excuse me. Besides all of that, things that we're related to, if we're 97% related to monkeys, how do you account for such a huge disparity between us? If we're only separated by 3%.
3% is key.
Well, that's what they say. I would say, I mean, we're not related to monkeys, so it really doesn't matter what percentage we are related to them, because we're not related to them. By the way, are human beings, this is kind of a trick question, maybe, are human beings animals?
Yes.
We have one yes,
Or mammals.
No.
we have one no, we have one we're mammals, I don't know what that means, yes or no.
Oh, I don't know.
I say yes.
Human beings are not animals. We're not. Now, evolutionists will tell you that we are because we're all animals, is what an evolutionist would say. But how we were created was different from the animals. How did God create animals?
he spoke and it
He
was so.
spoke, and they were. How did he create man, Adam?
Formed.
He formed him out of the dust of the earth and breathed into him the breath of life. We were created different. And it would have been on the board last week, but that was last week's confirmation class, not this week. But there are 4 things that make someone a human being. What does it mean to be created in the image of God? And one of those is that God formed us and breathed into us the breath of life. So we're different from animals. Now, we can have similarities to animals. We absolutely are similar to animals. And as Steve pointed out, you could call us mammals as long as you don't put us in the animal kingdom. But if you're going to put us in the animal kingdom, then we're not mammals. Although we have a lot in common with mammals. But we're not animals. Because God didn't create us to be animals. He created us to be human beings in His image. We are not animals. No matter how much evolutionists may try to convince us anything to the contrary. So how do you account for that 3%? We don't have to, because we're not related to monkeys. Now, morality, this is the next bullet point, is generally accepted as the biggest gap between human and animal life. Morality is generally accepted to be the biggest gap between human and animal life. And I think there might be some truth to that, although maybe not in the way that you think. Human beings are moral, but they're also very immoral. And just as a case in point, Hamas. It's one thing to attack other soldiers. And in some ways, anything goes in war when it's between soldiers. But Hamas did not attack soldiers. Who did they attack?
Women and children.
Women and children.
Babies.
Babies, yeah, which would be included in children. And now we have documents that have been found that said that was their goal all along, was to attack women and children. I don't know why, but that was their goal. Maybe it's because they wanted to provoke an international response, one way or the other. I don't know. And maybe you do know. I don't. But their goal was not to fight fair. They went after innocent human beings. And for that, they were rightly condemned. I'm tempted to go off on politics. I'm going to stop right there and just leave it at that. But there is a lot of immorality in the world. Oh, by the way, the same thing happened in Ukraine. Russians were targeting women and children there as well. And for all I know, the Ukrainians were targeting Russian women and children. I don't think that's really how it works, but maybe. So that's pretty immoral. And only human beings have that immorality. Animals will, or let's take a lion for example. Which member of a herd will it always eat?
The weakest.
The weakest, the slowest, whatever one can't get away from it. It's not because the lion made up in its mind, I'm going to thin out this herd by getting rid of the weak. No, it's just the easiest for the lion to catch. And so, in that regard, predators in general do God a service, if you will, by thinning out the weakest out of a particular herd. They're not doing it intentionally. Perhaps God is using it intentionally. I don't know. But the point is that they're not immoral to go after the weakest. It's just the easiest for them. Human beings, on the other hand, have choices and they often make bad choices. Moving on. Now there is evidence that there's a God gene that gives people morals. There's evidence that there's a God gene. Now, I don't think there's a God gene. I do think there is a God who wrote his law on each and every human heart. That's where our morality comes from. That's what a creationist would say. An evolutionist would say, there must be a God gene that's in each human being, or most human beings anyway, that give them morals. I don't know how they explain immorality, but... Now, I'm not sure how the theory of evolution accounts for this. So how do they get a God gene? Where did that come from? According to evolution, everything mutates. And if it's good for that organism, it'll stay. But a lot of the morality, the value that comes from morality, is not evident in a lifetime. At least not in the animal kingdom, for example. In human beings, maybe. But even so, if you were moral, you were unselfish, you gave away everything that you didn't need, how would that help you? Would it? I mean, again, as an evolutionist, would that help you? No. It would harm you, because now you have less than you had before. You have less resources, you have less property. They equate stuff with happiness, so you'd be less happy. I'm not saying that's true, I'm saying that's what they would say. So how would a God gene benefit anybody? Yes, it might make them more moral, and that might make them a better citizen, but it also is going to make them unselfish and poorer to the point that they just don't even have what they need to take care of themselves. How is that helpful for an individual? And of course it's not. Evolution says that, like everything else, it will eventually lead to greater well-being for that individual. So eventually it will lead to greater well-being. But that's not how evolution works. It doesn't say, eventually this is going to be helpful for you, so I'm going to force this change on you. No, it happens randomly, and if it doesn't help you, then natural selection sifts it out. There is just no valid explanation for how morality helps human beings be a stronger, better, healthier human being. There just isn't. Yes, if you space it out over time, of course, morality helps us. But evolution doesn't have that luxury of spacing things out over time. It's always an immediate change. Does it help or does it hurt? If it hurts, we're going to get rid of it. Now, does it make sense if you believe that you were created by a loving, caring, and yes, even judgmental God? Yes. It certainly makes sense if you believe that you were created by a loving, caring, and yes, even judgmental God. So morality makes perfect sense if you believe you were created by a loving, caring, and even judgmental God. By the way, why did I put the word judgmental in there? Why should that matter with morality?
Because if you do something bad, you're going to be judged.
Well, you skip one step, but you're going to feel bad first about doing something bad, and then later you'll be judged. Yeah. So morality has to presuppose a judgmental God, somebody who hardwires into his creation, things are good, things are bad. You'll feel happy if you do things that are good, you'll feel bad if you do things that are bad. That's because we have a judgmental God. Yes, Hazel?
Basically, the knowledge of what it means.
Yeah. Yeah. All right, next point. Vestigial organs. Again, this is what evolutionists say, not creationists. Vestigial organs are those organs thought to be leftovers from previous evolutions. So they're leftovers. But the body still has them because it hasn't weeded them out yet. So for example, the appendix is thought to be a vestigial organ, at least in human beings. And as it turns out, the appendix has been shown to be beneficial to humans. I mean, it's not a vestigial organ. Vestigial means leftovers. It also means things that are useless. Vestigial is not useless. Not in the cases of human beings. The appendix is useful, it is helpful, it is beneficial to human beings, such as helping fight diseases in young children. When our oldest son was, 3 maybe, he was really sick. And he was so sick, we had to take him to the doctor. Remember that? And the doctor said, he'll be fine. He'll be fine? He's barely alive. How can you say he'll be fine? Kids are strong. They'll be fine. And he was fine. But as first-time parents, it was our first time dealing with that. Do you remember what it was called? Rotavirus? Rotavirus. You guys know what rotavirus is? I don't know, some kind of virus that makes you real sick. And so Jake was real sick. But he got better. We did what the doctor told us to do, and he got better. So one of the reasons doctors can say kids are tough, they're resilient, he'll get better, is because doctors know that kids have something like an appendix that helps them fight off these diseases. So the appendix is not vestigial. By the way, tails are thought to be a vestigial organ, and even though we don't have tails now, according to evolutionists, we had them when we were pre-born, when we were unborn, still in the womb. We had tails and they just dropped off as we continued to mature. That's not true. And it's not observably true either. It's because some evolutionists created this diagram of what he thought an unborn child looked like, and it had a tail. It doesn't. We never did have a tail. But as far as I know, that drawing may still be circulating in various schools because people liked it. Because it showed an example of evolution. Look, when we were not yet born, we had tails. We did not. But for evolutionists, I mean, there's just nothing that they won't stoop to try to make their point. And by the way, evolutionists are very successful in trying to brainwash people. For example, earlier I asked if human beings are animals, and some of you said yes. We're not, but you have been convinced otherwise. I meet with a guy over in the jail every Friday, and last Friday he was talking about all these things about evolution. The earth is millions and perhaps billions of years old, and he doesn't believe that we evolved from animals, but he does think that we've been around for millions of years. And it's just discussing this with him and arguing a little bit, because he likes to be argued with. I said, you've been brainwashed. You're getting all of your information from TV, and a lot of it's just not true. And you have come to believe this stuff is true, and it was tough for him to acknowledge it. And I don't know that he ever did. But I said, just look here. And I pointed out in Genesis how it says God made everything after its own kind. He didn't have a problem with that. And I said, when he made the stars, they were for seasons and markings of time, and that was surprising to him. So there's just aspects of creationism that even, and this guy's a strong Christian, he's a member of the Assemblies of God Church, and he believes the Bible's true, and yet there are aspects of evolution that seeped into his brain. And his argument was, well, of course, time is a man-made construct. No, it isn't. God made time. He made everything, including time. But anyway, I'm digressing, but the point is we've all been brainwashed to varying degrees into believing some aspects of evolution are true, and they're not. All right, let's move on to immediate problems with this theory. Okay, what are the most obvious immediate problems with this theory? Well, we already mentioned one of them, the second law of thermodynamics. It disputes this possibility. The second law of thermodynamics says that all matter breaks down and becomes less complex over time. All matter. It doesn't matter what the substance is, it breaks down and becomes less complex over time. Rust is a great example of that. Rust is the deterioration of metal. It's not an evolution of metal, it's a deterioration of metal. So everything, all matter, breaks down, becomes less complex over time. As proof of that, the simplest of all cells, which is the prokaryote bacteria cell. Apparently that's the most simple of all cells. It is more complex than the space shuttle. Which, I don't even know that we have a space shuttle running around anymore. Have we had any launches in the last 5 or 10 years? No, I don't think so. But we know the space shuttle is pretty complex. But it's not as complex as a simple living cell. So if a simple living cell is that complex, how much more complex is the human body? Is it a mathematical possibility that random changes over billions of years led to the existence of man? The mathematical possibility of that, in other words, the chances of that are, according to scientific mathematicians, is 1 in 10 to the 40,000th power. Which means 1 with 40,000 zeros after it. In other words, statistically speaking, the possibility of human evolution is 0. There'd be 40,000 zeros and then a 1. In other words, it's 0. All right, second of all, the law of conservation of matter and energy, which once again we mentioned before, that's a law that says matter can't come from nothing. It has to come from somewhere. According to the Big Bang, matter was just here. And it wasn't created by anyone. It's always existed. Matter has always been here. Well, that's just not possible according to the law of conservation of matter and energy. Matter and the energy of the explosion all had to come from somewhere. Something had to be a catalyst for those things to happen. And even when you talk about the explosion, well, what precipitated it? I don't know. And I'm saying that as an evolutionist. I don't know. They don't have any idea what caused the Big Bang. They just know that it happened. All right, now here's one we haven't mentioned before. The law of biogenesis. The law of biogenesis says that life cannot come from non-life. Life cannot come from non-life. The Bibles that you have sitting in front of you are never going to turn into anything else other than, dust. But they're never going to turn into a human being. Rocks are not going to turn into human beings. Chairs are not going to turn into human beings. Nothing that is not alive will ever become anything that is alive. Living cells can only come from other living cells. And that's a universal law. And again, when we're talking about science, laws are things that have been proven time and time again such that they cannot be disproven. So there has never been a time where something alive came from something that wasn't alive. So how do evolutionists get around that? They say there was a time when this law wasn't in effect. Well, you've had billions and billions of years for the universe to evolve and change. It didn't always have the same laws that it has now. There's no proof of that. But this is another law that makes the theory of evolution difficult proposition to hold. Now, I don't remember what the name of the test was called. Maybe somebody in here does, when they tried to combine chemicals to create living things. Anybody know the name of that? I don't remember either. But the best they could come up with, this is the next bullet point, by the way. Scientists have been trying, with a plan, to create life out of non-life. So they've been trying, it's not random, they're trying to create life out of non-living matter. And the best they have done is to create amino acids. Amino acids are the building blocks for living matter. They are not living matter. And that's the best that evolutionists have been able to come up with, is to create amino acids. If they can't do it, even as they plan to do it, or they try to do it, can you imagine the possibility of it happening randomly? Again, it's not possible. Next bullet point. Despite researchers' best efforts to the contrary, the gap between living and non-living cells has been growing larger as more research is done. So the more we study the difference between living and non-living things, the bigger that gap comes. Not smaller, bigger. Next bullet point, the cell principle. The cell principle is a principle that said basically cells can only come from already existing cells. So it's a principle, not a law. But what it says is the same thing as the law of biogenesis, that cells can only come from other already existing cells. Now, non-living things also have cells. But again, no cells self-exist. They always come from other cells. The information theory. This may or may not be where we end today. The information theory says that since cells are coded, in other words, they're given information, that's what enables them to continue their given characteristics. My cells said I was going to be short because both my parents were relatively short. I guess I got my lack of hair from my mom, because I guess baldness passes down through women. I don't know. I don't know if that's true or not, but I just heard it mentioned on a sitcom the other day. But anyway, I am who I am because it was in my parents' information, in their cells, and they passed that on to me. Because of this information, cells are able to reach their full potential. So whatever you're going to be, whatever your full potential is, it's already in your DNA. It doesn't mean you're going to become everything in your DNA, but you will not become anything that's not already in your DNA. So whatever you are now, it's because you were given that information in your DNA when you were conceived. So that information that's in your cells is what has enabled you to reach your full potential. This information is passed on by reproduction. So obviously your parents had sex at some point and you were the result. So they passed on information to you. But new information was not created. It is never created. It can't be created. Cells cannot make up new codes of information. They cannot do it. New genetic information can only be introduced through crossbreeding when a new offspring is born. So again, one of the parents must have had something in its genetic makeup that it could pass on to this offspring. Now, human beings are not crossbreeders because it's human beings and human beings. If somehow a human being was able to have a baby with a deer, that would be crossbreeding, which it has happened, but I don't think that any offspring have been created by it. But it has happened. I know that for a fact. So anyway, but somebody mentioned this last time. There's a mule and a donkey and something else. Which one is the result of the crossbreeding?
Mule.
The mule is the result of what? A donkey and a horse?
Horse.
Donkey and a horse, okay, so a mule is a result of that. Because they're not similar, or, well, they're similar, but they're not genetically the same. So that's why a mule is different from a donkey and a horse. But that mule is still an example of microevolution. In other words, it's not a radically different animal. It's not the same as a horse, and it's not the same as a donkey. It's a hybrid of them, but it's not something that's unlike a donkey or a horse. And that's why it's an example of microevolution. Microevolution, I think we talked about this on the first day, is changes that happen within a species. So we have different colored hair, different heights, all kinds of differences between us. I don't know that any of us have called anyone else in this room by the wrong name because we were so similar to somebody else. We're all very different people. But that's microevolution because we all look like people at least. None of us look like something else. All right, so for example, there's a bullet point I have to mention first. Changes must take place at the cellular level first. First and always, changes take place at the cellular level. Cells have to change at the molecular level in order for visible changes to take place. So again, before anyone's going to see something different about you, it's already going to have taken place in your genetic code. So cells have to change at the molecular level first, and then the visible changes will take place later. So for example, a creature can't fly unless its genetic code adds information leading to the genetic changes in tissues. What makes it possible for birds to fly? Wings, but just because you have wings doesn't mean you can fly. What else?
Feathers, like forest bones.
Feathers, yes, but what did you say, Hazel?
Have to have really light porous bones.
Right. The bone structure is different from ours. What's in our bones?
Marrow.
Marrow. What's in a bird's bones?
Air.
Air. I mean, there might be something in there, I'm not sure. But they're pretty light. If you've ever held a bird in your hand, probably a dead one, because you probably couldn't hold a live one, they're pretty light. That's what it, why is that funny? Of all the things I've said, that was funny? So, that's what makes birds capable of flying, is the fact their bones don't weigh anything. And when they've got feathers and all the other, and wings, obviously, that's what enables them to fly. So if you were ever going to change into a bird, you'd have to change your bone structure first. I mean, that's one of the amusing things about dragons. There's no way that dragons' wings could lift a dragon off the ground, but it's fantasy, so nobody says anything about it. But in order for a dragon to fly, its bones would have to be really, really, well, let's say thin, but I would say brittle. I just don't think there's any way that dragons could fly, but that's a whole other point. But so it's not just having to gain feathers, your bone structure has to change altogether. So in the meantime, by the way, in the meantime, while you are evolving as a creature, what will happen? When your arms are changing into wings, what happens in the meantime? This is going to require a little deeper thinking. You start with arms, you're working your way to wings. What happens in the meantime?
There's neither.
You have neither. And if you have neither arms nor wings, guess what's going to happen to you?
You're pretty helpless.
You're going to die because you're helpless. That's the other thing that evolution doesn't mention. There must have been millions of years of changes in between. And why did those creatures survive those millions of years of evolution when they had neither arms nor wings? They had neither one. So, that means, next bullet point, almost all cellular mutations is detrimental, at least at first. In other words, it's harmful. It is not helpful. Only foresight would enable natural selection to know that eventually changes will be beneficial. Only foresight, only the ability to know that someday these changes are going to benefit you. Well, that's not how natural selection works. It doesn't work on some days. It works on right now. Is this beneficial for you now? No? Well, then you're going to die. That's how natural selection works. So in order for evolution to be true, natural selection has to not be natural selection. So for example, morals, the God gene, that's not beneficial for human beings, except over time. But in this one life, if you give away everything that you can't possibly need, you're a worse off creature than you were otherwise. So mutation is detrimental. The only way that natural selection could allow those changes to take place is with foresight. The only examples of beneficial changes are the resistance of certain viruses and insects to the things meant to destroy them. Now it's beneficial in terms of it allows them to stay alive, but it's not beneficial in terms of their actual genetic makeup. It is still harmful because information has been lost. So as these mutations take place, information is destroyed. So think of it like a net, and you're a butterfly that can't fit through the net. And that's how you catch butterflies, right? Is in a net. Well, what if you had a mutation that made your wings really small and you could fit through the net? That was a beneficial mutation for you, right? Because now you're not getting caught in a net anymore. But you did lose information. You became less complex than you used to be, as a butterfly anyway. So even though that was a beneficial mutation, and it did help you, I don't know how many butterflies are being slaughtered every year in nets, but if there were a lot, then that mutation would certainly be beneficial. But the organism would become simpler, not more complex. And lastly, what becomes impossible? Reproduction. If you are in the process of changing from one creature to another, at some point, your reproductive organs aren't going to work. Because it doesn't work like flipping a switch. It's not like one day you're this, next day you're that. We're talking millions of years of changes. And at some point in those millions of years, they're just not going to work. Because nothing works in the process of changing. When you're a missing link, which there aren't any, there are aspects of you that just don't work anymore. And at one point, it's going to be your reproductive organs. Those don't continue to work every day until you change. At some point, they don't work. Just like nothing else will work. The eye, the evolution of the eye. They can't explain that. How did an eye evolve? Well, we know that eyes didn't evolve, but they can't explain it because it's just too complex. Did you have your hand up, Jeff?
I did. One thing that's always baffled me, how they can never explain, is the fact that evolution, in evolution, if it's to be possible, both the male and the female would have to evolve at the same pace. And that's virtually impossible.
Yeah, that's a great point. Yeah, because if you just have men running around,
Then it would be,
can't reproduce. Well, who
I
knows?
mean, that's the diagram they show. They show a small ape, a little bigger ape, a more ape, and then a man.
Right.
But they don't show the female counterpart or male counterpart.
That's an excellent point, Jeff. I hadn't thought of that, but you're right. That's another example of something that makes evolution really, really hard to believe. The last point I'm going to say, and then we'll wrap up. I don't believe in evolution because it takes too much faith. There's just so many things that make it really, really hard to believe. I can't believe it because it takes too much faith, and I don't have that much faith. Think about that and laugh about it. It strikes you as funny.
Well,
All right, go ahead, Mary.
last word.
Oh, I'm sorry. Unless the change is immediate. Sorry. Reproduction is impossible unless the changes are immediate. Thank you for catching that. All right, God's blessings to all of you. We'll see you next week.
These are a lot.